Can the average rate of change of a function be constant? Yes. In fact, the slope of a secant line, which is 2 points on the graph, is the average rate of change. So the slope of that line is the average rate of change, I should say. But if the function is a line, then of course the slope of that line is the average rate of change, and the average rate of change is a constant, which is the slope. Kind of circular, but that's what's going on. If a function is increasing and then decreasing, the extrema is a maximum. So in other words, you go up, then you go down. How are the absolute maximum and minimum similar to and different from local extrema? Well, all absolute max and mins are local extremas, but not the other way around. So if it's local, it doesn't mean it's absolute. But if it's absolute, it is local. How does the graph of the absolute value function compare to the graph of y equals x squared in terms of increasing and decreasing? They're identical. Absolute value decreases from minus infinity to 0 and then increases from 0 to infinity. Y equals x squared decreases from minus infinity to 0, increases from 0 to infinity. Okay, let's try this problem. P of x is equal to 3x plus 4 on 2 to 2 plus h. Alright, so again, average rate of change, right, that's what we're supposed to find in this problem, is just the slope of the secant line, which we can find by doing x2 minus f of x1 over x2 minus x1. Now, what are x2 and x1? Well, this one, that's your x2, and this one, that's your x1, like that. So all you have to do is plug those in. Now, we should know what our answer is because this is a line, so the average rate of change is the slope. So our answer should be 3. But let's go through all the steps. So we plug this in, so we get 3 times 2 plus h minus, or plus 4 minus, now the whole thing, so we got to put this in parentheses, 3 times 2 plus 4, like this. So we plug in our 2 points, plug them in down here, so we get 2 plus h minus 2. Alright, so now what I'm going to do is, I'm going to distribute the 3, so I get 3 times 2, and I'm not going to multiply those together. I mean, you can, doesn't really matter, but I'm just, for other later problems, it actually works out kind of handy to not do that, and I'll show you why. Distribute the minus, and you get 2 plus h minus 2. Now you find the things that subtract out, which are these two things, right? They subtract out, and those two things, they subtract out, leaving just a 3h. In the denominator, these two things subtract out, leaving just an h. The h's divide out, and we're left with 3, and that gives us our answer for that problem, which is what we expected because the slope was 3. So let's try this one. F of x is equal to 2x squared minus 3x on x to x plus h. Alright, so again, this one is our x2, and this is our x1, so we want to find f of x2 minus f of x1 all over x2 minus x1, like that. So let's just plug it in this nut. So we get our average rate of change. It's going to be 2 times. Now let's plug in our x2 minus, now subtract. So this piece that I have right here that I just wrote down, that piece right there, that's that one. Okay, so now I'm going to plug in just the x, so I get 2x squared. Now remember, this is subtracting the whole thing, so I have to have that parentheses around that pair of terms there. And then the denominator, x2 minus x1. All right, so now let's just multiply this one out. So we get 2, and of course, the thing we're going to multiply out goes back to the algebra formula. A plus b squared is a squared plus 2ab plus b squared, like this. So I'm just to do it quickly, you can do it, have those things memorized. So you can just do x squared plus 2xh plus h squared minus 3 times x plus h. Let's distribute this minus, so I get 2x squared minus plus 3x all over x plus h minus x. So let's distribute the 2 and the 3, so we get 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x plus 3x all over x plus h minus x. So now let's do all the subtracting things, right? So those two subtract out, those subtract out. What else subtracts out? That one and that one subtract out. And notice that everything that's left has an h in it. So I have 4xh plus 2h squared minus 3h all over h. So h divides into each one. Let's do it this way. Let's factor it out. So that gives us 4x plus 2h minus 3 all over h. Those two divide out with our final answer of being 4x plus 2h minus 3. All right, so let's look at a graphic version of increasing and decreasing. For the following exercise, use a graph of each function to estimate the interval on which the function is increasing or decreasing. So the first one we kind of talked about already, but so let's do this one, because this breaks it up into over the whole domain, because you have the arrows, so you know what's going on forever and ever. So if I look at this piece right here, right, I'll just try to draw this in as best I can. You get that if you put a little dude on the side over here, right? Think of some guy over here that's just walking from left to right, right? He's always walking from left to right. So as he walks from left to right, he's going up. Now, he's going up, but that's not what they're asking for. They're asking for the interval on which it's increasing. So they're talking about in the domain. So they're talking about domain. So we have to figure out, you have this spot, say we'll call it 2.5. So from negative infinity up to 2.5, it's increasing. Now again, if you start here at 1 and you go this way forever, right, you get from 1 to infinity that it's increasing. Now at these spots right here and right there, they're not increasing or decreasing, so we don't include them in the interval, right? So if I were to write where it's increasing, I would have, let's see, I'll change this up just a little, minus infinity, round bracket, because it always does, to negative 2.5, and then union 1 to infinity. And that's where I would say that it's increasing. Oops, I forgot the parenthesis. Okay, so now where is it decreasing? So decreasing, right, if I'm walking from left to right, he's walking downhill on this spot right here from negative 2.5 to 1. And so we would say that's decreasing in that range right there. So we would say we are decreasing from, sorry, I'm not very good at writing with a mouse, but here we go. So we have from minus 2.5 to 1, like that. And that would be the interval where it's decreasing. So let's do the story problem. A driver pulls up to a gas station. I'll add on my own flair here, right? And he gets out. He's going to pump the gas because this isn't New Jersey. You do know that There's only like 2 states in the whole country that have gas like in New Jersey, so I know this isn't quite as relatable. But, okay, he looks at his watch. So he has his watch here, right? And it says 3:40. He starts pumping gas. So he plugs it into his car, starts pumping the gas. And when he gets done, right, it says 3:44. And in that time, he pumps 10.7 gallons of gas. So the question is, what is the average rate of flow for the gasoline to the tank? All right, so remember, average rate of change is still f of x2 minus f of x1 over x2 minus x1. So where is this in the problem, right? So this is, the top is the gallons. How many gallons does he pump? Well, this total sum here is the 10.7. Because he really, if you want to think of x2 and x1, is that x2 is the 3 minutes and 40 seconds, and 3 minutes and 44 is the time that he does, right? You could think of it maybe like this. This is your x2, and this is, or your x1 and your x2. And then, how much gas has he pumped this time? 0. How much is he here? 10.7. So the top is 10.7 minus 0 over the bottom, which is how much time that he has. We really don't need the 3's, right? 44 minus 40. So this is 10.7 over 4. Now we can plug that into our calculator.
0.7.
And we get 2.675 gallons per minute, like that. And that gives us our rate of change for that problem.